Hi, everybody. Thank you for joining this session. Today, we're going to be talking about Envoy, proxy, and GraphQL, how you can deploy only once and have an API, a GraphQL API, secured and monitored. So, your speakers today, my name is Sayah. I'm a field engineer here at Solo. I help customers adopt service mesh and API gateways. And with me today, Kevin.
Hi, Kevin. Tech lead here at Solo. Former tech lead of the Gloo API gateway team, and currently TL on the GraphQL initiatives here within Solo. So that primarily maintains building GraphQL server into Envoy. You'll hear much more about that today. And then bringing that to both our API gateway and service mesh products as well.
Awesome. Yeah. Thank you, Kevin. If you guys have any questions during the session or after, please send us a message here or on Slack. We're always happy to help. All right. So today we're going to be talking first about just a quick reminder regarding Envoy, how it is used, and we're going to talk a little bit about GraphQL, how to secure actually a GraphQL endpoint with Envoy, and then we're going to go about why should we actually embed a GraphQL server within Envoy? What's the benefits that we have there? We're going to deep dive into a couple of examples, and then we're going to end up with a demo. So first, Envoy proxy. If you guys are familiar with it, if not, Envoy is a super powerful API proxy that is actually used mostly everywhere now. You can see it from, like an edge deployment securing your ingress traffic to your clusters or to your infrastructure, or it can also be used in service mesh between services. It's a small, robust, and easily, manageable proxy. It is one of the main building blocks for all the cloud native technologies. It is HTTP2 first. It supports gRPC. It supports low level protocols, and it is actually driven with an API. So you can configure everything through a control plane. And we're gonna take an example of Gloo later. Gloo is basically a control plane for Envoy. And one important feature there is that you can customize it. So you can add your custom filters to enhance either security or the processing of the requests. And this is something we leverage here a lot at Solo. We add our custom filters to Envoy to either add features like data loss prevention, like request transformation, and so on that we're gonna talk about later in this presentation. So the way Envoy can be used, and this is just an example of how to use Envoy as an ingress to your community service. Again, as I mentioned, Envoy can be used in the service mesh scenario. We're going to deep dive into mainly just the edge scenario today to see some contrast. So Envoy can be in front of your cluster, right? And it can act as an ingress gateway, directing traffic to your cluster, to your REST endpoint. And, it can direct based on, it can route traffic based on headers, have high decision on the L7 level. It can also, be customized to enhance security there. So you can add your, let's say, API key feature or OIDC or so on, right? So the way it works in Envoy is through the Envoy filter chain. Okay, so when a request hits Envoy, then you have multiple filters getting activated to either enhance the request or apply some sort of authorization on it before actually delegating this request to the backend. Okay, so in this example here, we're looking at a set of filters enabling external auth, for example, and then doing rate limiting, and then transforming a gRPC call to a REST call. But you can add your custom filters. Okay, so here at Solo, we have multiple custom filters we added to Envoy. Some of them let's just take an example here. We have a WAF filter. We have WAF, a web application firewall. We have data loss prevention. Gonna see me referring to DLP later. It's for data loss prevention. That allow you to mask sensitive data, going through your request. Right. So if, let's say, your endpoint serves like social security numbers, you want to mask this sensitive data. We have an AWS Lambda filter that allow Envoy to act as a fast gateway. So it can call out directly to your Lambda function, get the data there, and you can apply the authentication, authorization, everything to this call. Also, request and response transformation and many more. So this is just a quick introduction to how Envoy works and what filters we have here at Solo, even if this is not the final list, and we have many more. And we invite you guys to check our documentation for more in-depth examples. Okay, so now that we saw how Envoy works, and we saw the power that we can add to just a simple API processing, assuming you have REST endpoint in your cluster, we see how we can easily secure it and rate limit it and many other operations you can apply on the request. But a lot of customers and users like the REST approach, but also want to optimize the request processing. From client standpoint, introducing, for example, GraphQL. So what is GraphQL? Mainly, it's a query language for your APIs, right? So you will deploy, you describe your data as a graph, and you allow a client talking to this endpoint to fetch data from multiple data sources. Assuming you have 10 different microservices, instead of doing a REST call, if instead of making your client talking to 10 different REST endpoints, you'll have one endpoint that will collect data from these different data sources. Okay, that optimize a lot of things. First, it allows the client to not overfetch data or underfetch data. It allows you to describe all your data in a manner that can be easily consumable. Now, if you want to use GraphQL today and secure it with, for example, an API key or through a data loss prevention filter, you'll have to put it behind a gateway. Like in this use case here, we can look into using Envoy and the authentication authorization mechanism, putting that in front of the GraphQL server. So the client will call the gateway first, authenticate, and then the call will go all the way to your GraphQL server, get processed, collect the data from different data sources. And then the response will go back to the gateway, where we're going to apply, let's say, a data loss prevention filter to mask some sensitive data before reaching the client. And you see how many network hops we have there, right? And so this is kind of a standard way of deploying or enhancing security for your GraphQL server today. Now, we can see that there is a lot to optimize there. Okay, so some of the things we can optimize is the network performance. Now, if I have two different deployments, if I have a network hub, that means that I'm adding another variable, which is the network, to my request, right? So you can definitely enhance your performance, your request performance, by just reducing the number of the network hops you have, right? Again, another problem you can have is mainly just managing two different deployments. So if you want to have an API gateway in front of your GraphQL server, and you want your security team to enhance the security in both components, they need to be familiar with both, right? So they need to be familiar with your gateway, and they need to be familiar with your GraphQL server to enhance security. So imagine if you have both in the same component, that will just have to be familiar with one technology and apply the same principles to all the requests, right? Because ultimately, a GraphQL API, it's still just an API. Okay. Another thing is obviously enhancing, how to learn these new technologies. You can, if I have multiple components to get up to speed on one component is way faster than two. Obviously, if you hire people to manage your security. Another thing is the in-depth field control. Now, if you have the GraphQL server within Envoy, right, you can have control over the data within the GraphQL server. Like for example, if you want to apply certain authentication authorization resolvers and or get in depth like per field, definitely you can reuse all the concepts you have in your gateway all the way down to your GraphQL server and field that you're exposing there. Another really important concept is, if you have GitOps already today and you have pipelines to allow you to deploy configuration and secure your endpoint, if you can describe first your graph plus your security that you have on top of your GraphQL API through a GitOps approach, that's really valuable. That will allow you to roll out new configuration easily, to roll out easily, and many more other operations. Another concept is also reusing the same metrics collection and logging that you have today for your API consumption to your GraphQL server. You can apply alerting on certain, let's say if endpoints are not available, you can collect the same metrics that you have already and alert based on them. And also it's going to be easily, because you can also integrate easily with, let's say, Datadog and any other technologies you have to collect data. Okay, so now we saw that having a single deployment will definitely help a lot, first for security, and plus for having your team managing only one product. And from there, we're gonna deep dive into a couple examples, and I'll let Kevin talk about this.
Fantastic. Thanks, Adam, for the getting us started here with the introduction. So the very first thing I'd like to do is just run through some example, scenarios that we see as realistic opportunities, just places an organization might be in, how GraphQL and Envoy can help here, and just provide real clarity on some of the value that it provides. So for example, the scenario here is, we're an organization where already have the Gloo Edge API gateway, built on top of Envoy proxy. We've primarily exposed or written our services with a REST style. And we've decided that we like GraphQL. We like what it offers. We like to solve the underfetching problem. We like to increase performance by doing most of the requests on the server side. Make it easier for developers, tab space their way through and discover their schemas. And we want to do this in an incremental way. We want to add some services incrementally. We don't have a GraphQL server yet. Additionally, we want to have the same organization-wide data loss prevention or DLP rules to scrub all access logs of PII or personally identifying information. So the example we have at the bottom there, you can see our JSON response has like a fake Visa card and an S social security. We can scrub most of that. The scenario here is we want to comply with legal. We want all of our access logs to be scrubbed of this data. Legally required to do this. So most companies today, they have to secure both their API gateway and their GraphQL server. If you had a separate server deployed, you need to re-implement this logic to be compliant. Your access logs for both will be separate. They both need to scrub the data. But by merging or writing a GraphQL server into Envoy, you have one set of access logs. You only need to implement this once. The same DLP rules don't need a single source of truth to be generated for both. So it's more manageable. Further, we can also do things special for GraphQL that make it more performant. So for example, we can take these DLP rules and we can apply them on a per field or per resolver level, whereas it would be more difficult to do when they were separate. And this can lead to improved performance. So for example, a lot of the DLP rules, they parse the return response and take a regex and apply that regex and replace certain aspects of the response based on a regex match. That regex might be difficult or expensive to parse, but if we can do it on a per resolver level, then we're parsing less and we're going to get more performance. Ignoring the network hop we're already saving, we're going to again improve performance. And this is something we only get when we embed the server in Envoy. So from here, I'd love to move to another example. So let's say again, we're an organization, but now we're talking about service mesh instead of an API gateway. So let's say we're service mesh, we have Istio or perhaps several Istio installations managed by Gloo mesh. We've configured JOT authorization via the request authentication and authorization policy Istio resources. Examples of those resources are at the bottom here. And let's say that we want to use these JOT authorizations to control access to certain policies, in our GraphQL environment as well. So you can see here on request authorization, we have defined our JOT rules, specific issuer, and a way to access the key server. And then we have JOT rules for how to allow the request on the authorization policy, with certain principles that we need. And together this constitutes access, or things that we need from that JOT to access a destination in Istio. And we want to go ahead and reuse this same policy to define access to certain GraphQL primitives, such as making GraphQL mutations. So the example that we've constructed here is, let's say we have this JOT, and this JOT has a claim that means that you're like a member of the admin organization or the admin team. And so you can only access certain backends if you're an admin, which makes sense. But perhaps you also only want certain mutations in your GraphQL super schema, the total graph, to be, mutated by admins as well. And so rather than defining two sources of truth, we could use the same, Istio definition of a JOT and then reference that, and we should be able to gate our GraphQL mutations by that same exact claim defined once. Further, we could just use it to strengthen our defense in depth case. So we could just layer certain fields at a field level, or the response itself by the JOT as well. It's not always the way that things are done, and that's what I mean by defense in depth, because oftentimes if you also want to gate the upstream itself, but it's not necessarily a bad thing to go ahead and gate the JOT itself in a field level rather than just a mutation or things like a subscription. So there's value there as well. Pivoting from these two very specific examples, let's talk a little bit further about what other things can we do. So obviously these aren't the only things that we get by a declarative approach embedding GraphQL and Envoy. There's so much more. And just to kind of give you a flavor of some of the things I'm talking about here is in an existing API gateway or service mesh built on Envoy, we already have a lot of features. For example, rate limiting and external authentication. Just filters that define access to secure your APIs. But additionally, we also get a lot of resiliency features, for example, things like timeouts, circuit breaking, load balancing, health checking, outlier detection. We also get a lot of observability features, so things like metrics, tracing, alerting. A lot of these things already come feature rich and automatically with Envoy, and others you've already configured per upstream as part of your API gateway or your mesh. So you've either put the work in, or Envoy is intelligently doing this for you. By embedding a GraphQL server in Envoy, we define our vault resolvers. Envoy originates the requests to all of the upstreams. And by doing so, it uses the Envoy clusters. It kind of reuses logic from the router filter. And what this means is, for free, you're getting a lot of these other resiliency features and observability features that you're used to having. And you don't have to redefine or rewrite any of this logic in resolvers. So for example, it's, Envoy is aware of which upstreams are circuit breaking right now, or what a load balancer policy we want to use, or which ones are actively healthy from active or passive health checking. And our resolvers get to reuse that logic, and you don't have to define it as a user, because either it's already there or you've already defined it. But additionally, we get more for free. So doing things with declarative resolvers is really nice. One very specific example is per request caching is a lot easier on the user. So if you're familiar with GraphQL a little bit, there's a library open sourced by Facebook called Data Loader. And Data Loader is basically the library that they often write around resolvers when you define resolvers programmatically rather than declaratively. And it's used for batching and caching. And so what the user has to do is provide, if you're unfamiliar, a batching function. You have to say, how can I group a bunch of requests into a single one? So think, a large SQL query with a bunch of IDs instead of per ID. And also can cache the results. So it can be smart and say, hey, I'm resolving these fields and I've already made this request to this upstream. I'm going to reuse the response and not hammer my backend. And so it can cache, but usually requires that the user provides a caching ID. We can do per request caching because our resolver is declarative. We know exactly what the request outgoing is going to look like. And without providing an ID, for example, we can do smart caching. So no user configuration provided, we already can do some caching for you that otherwise would require user intervention. You get optimizations as well. Other things that we get for free with declarative resolvers, obviously it's been talked about before, but GitOps, everything that comes nicely with GitOps. So a nice version edit history, secure controls on who can make edits to your GraphQL service, your full graph. You also get what I like to call standard resolvers, in that because they're declarative, it's easy to look at, and it's also easy to understand. If they're all programmatic, you have to read a lot of source code. They might not follow the same style. You kind of have to follow the same style when you follow our declarative model. And then lastly, validation. We can do simple things like make sure that there's no fat fingers in a remote cluster location. We can do the standard validation that comes in the control planes that are driving Envoy. This can be leveraged as GraphQL as well. And all of these benefits come without losing any of the features that you're used to. So other security features you might be used to in GraphQL features are things like query cost analysis. So figuring out which queries are expensive and how to limit them, or persistent queries, making sure we only run queries that have been approved for production. Things like that we can still do. There's no technical limitation on the implementation of the GraphQL server that we embedded in Envoy. We just get other things for free on top of as add-ons. And that's really the vision of what we're doing here. So from here, I'd love to pivot to the demo. The demo here mirrors pretty much exactly our use case number one. So we have an API gateway, we're an organization. We want to authenticate it with an external authentication policy, and we want to scrub our requests or access logs using data loss prevention. And we want to do this in Envoy with our embedded GraphQL server. So thankfully, we have Adam. He's prepared a live demo for us today, and I'm really excited to hand it off to him.
Yeah, thanks, Kevin. Yeah, so let's take a look at how we can deploy a GraphQL API and secure it with Gloo. Okay, so let's start by using an empty cluster here. This Kubernetes cluster has only Gloo installed. So what we are trying to achieve during this demo is to create some services within our cluster, demo services. Then we're going to create a GraphQL API that will aggregate data from these three different data sources, and we're going to secure these endpoints. Okay, so first step here is to create some services that we're going to use. In this example here, I'm using the book info demo application. It is just three different services. One is called product, one is called review, and one is called rating. And these three different microservices, we're going to use them to create one graph that will fetch data from these three different endpoints. And before we start here, in the meantime, since this application needs to start first, I'm going to walk you through core concepts here in Gloo. The two main important ones are a virtual service and an upstream. A virtual service is the routing configuration in your gateway. It will match on certain domain, and it will apply some policies, and then to route to a destination. Like taking an example here we're matching on any domain, and any path will route traffic to this upstream, which we call my upstream here. That can be anything. An upstream is just a representation of a destination. An upstream can be a Lambda function, it can be a static service, it can be a Kubernetes service, it can be a console service. There's different type of upstream that you support in Gloo. All right, so now that we are familiar with these two concepts, first the virtual service for the routing and upstream, we're going to see how we can first use them to route some traffic. So here, once the services get created in the cluster, Gloo will detect them, and we're going to create Gloo will create an upstream for each service. So let's take a look at the upstreams created. And here we'll see that we have this new upstreams, which is the detail service, the rating service, and the review service that got discovered, okay, in the product page. Now, if we take a look at one upstream, system-yaml, we'll see that an upstream, it just again, it's just a representation of a destination. In this case, it's a kube service within the same cluster. All right. Now that we have our app streams, we're going to create our GraphQL API. And for that, we'll go and create a GraphQL schema CR. And here's an example of an API that will represent these three services. Here, we'll see at first the GraphQL schema. You just need to define the resolvers. Okay, so here, for example, I have a REST resolver that will go and fetch data from this service called product page on this certain path. Note that today we support the REST resolvers and gRPC resolvers, but in Gloo Edge and Gloo Mesh will support also WASM resolvers and database resolvers in the future. So once we create our resolver here, and we have different ones, we have one for author, one for pages, and one for year, and basically all the resolvers we need, we can go and create our schema. So here, we can define mainly our types, and we can define the query. In this case here, I'm representing a product type, a review type, a ratings, and then I'm using them basically in a query. Here, that's all you have to do to define a GraphQL schema in Gloo Edge. You just create one CR that is definitely GitOps friendly, where you can be persisted in some Git and get deployed to your cluster. So here in this example, we're gonna create it. So apply it to the cluster. And once we have this GraphQL schema, we can use it in the routing. So again, we can use a virtual service to route traffic to this GraphQL schema. And let's take a look at one virtual service. In this case, it is the virtual service, the YAML. It's pretty straightforward here. I have matching on anything, and it will route some traffic. In this case, all the traffic to the slash GraphQL will go to, so yeah, the slash GraphQL traffic will go to the schema we just defined right now. And all this is just the course section for us to be able to use any web UI to explore the schema. Okay, so this is pretty straightforward here. Again, I'm defining the matching, defining on which path I need to match and where the request should go. In this case, it's matching on anything. It's going to go to book info GraphQL schema we just defined previously. All right, applying this. That should be enough for us to expose an API, a GraphQL API. Let's take a look quick here. And I'm using Altair in this example here just to query my services. So I'm going to call the endpoint I just exposed using my virtual service. And I'm going to use this query here that will fetch data from 3 different data sources. Let me run the query. And we'll see that I get data from these 3 services. And this is the results we have here. Here's a product reviewed by different reviewers, and we have some ratings. And you see that we created an API basically just using Envoy. We sent the configuration through our control plane, which is Gloo Edge. This configuration got replicated on our data plane, which is Envoy. And we exposed a GraphQL API. All right, so this is the first step. We see that it's easy to expose any GraphQL API. Now, let's take this a step further, and let's secure this endpoint using an API key. So to do this, we'll basically just create the API key configuration in our cluster. In this case, to secure the endpoint, I just need first to create an API key secret. And if we take a look at the secret itself, it's just a basic currency secret with the API key data. Okay, so in this case, this is the API key I'm going to use. And Now, I'm gonna apply an auth config. So once we created the API key, we're gonna need another configuration, which is what we call auth config in Gloo Edge. The auth config is just a representation of your authentication authn auth. So if we take a look here at one auth config for the API key, it just describes that it needs an API key authentication. And I invite you to explore all the other options we have in Gloo Edge. We have many other options that you can use in the auth config. You can use OIDC workflow. You can use basic auth. You can use OPA, Open Policy Agent for auth. And you can also use your custom authentication. Let's say use HMAC. You can definitely create your custom authentication, add it to our authentication server. Okay, so once we create the auth config, that's all we need. Here, we're gonna just reference this CR, which is the auth config CR, in our virtual service that we created previously. So let's take a look how the virtual service would look in this case. So, no, wrong one, virtual service API key. And we'll see here that we were just using the same virtual service. This time we're just enhancing it, adding the API key support by just referencing the CR we created. Okay, so here, it's all we need in our virtual service to enforce an API key. Let's apply this configuration. All right, now let's check if we can make a request. And see that we have here a 401 unauthorized, and that's mainly because of our API key, right? Now we'll have to basically we will have to pass the API key so we can call the backend, right? And here is how to do it. We're gonna have to go under setting the headers here, and we're gonna define a header called API key. And I'm gonna grab the value of the secrets I just created and save. And let's make a request again. There you go. We'll see that now using only one simple step, we enforce an API key security at the API level, right? And think about it, you can, again, use all the authorization mechanism we have in Gloo Edge to achieve the same result. Okay, good. Now let's try another feature. So now that we secured our API, our GraphQL API using an API key, we need to make sure that when calling these endpoints, we want to mask any sensitive data. And for that, we're going to use a data loss prevention filter. Okay. So in this example, we're going to use a DLP policy to mask the reviewers. But think about this when you want to mask social security numbers, account numbers, any sensitive data can be masked. All right. So to do this, we'll just have to go back to our configuration here and take a look at a DLP example. And here is a virtual service with some DLP configuration. Again, using the same virtual service we used previously. The only addition here is this DLP section. The DLP will say, I'm going to match on certain rejects. And in this case, I'm just using a simple one, reviewer. It's going to match on any string reviewer on my GraphQL API. And I'm going to mask 50% of it with this asterisk character. That's all we need. So applying this configuration. And there you go. Now that our virtual service is configured, let's go back and make another GraphQL query. So going back here, same again. Let's make a call. Just know that now I have reviewer still in clear, but now if I make a call again, see that data is masked. Okay, so this is a quick example to what you can use. We actually exposed the GraphQL API and we secured it using an API key, and we masked some sensitive data using DLP. But we support many other filters. So I invite you to check our documentation here for all the other core concepts you can use to protect your GraphQL endpoint. With that being said, this is the end of our demo and our talk, and we are happy to take any questions. And thank you for attending.